Let's get our heads around what's going on here. It's starting out stationary, it's got no velocity. And it starts to get faster and faster and faster and faster, increasing in velocity until it peaks and then it starts to slow down again. And it steadily decreases in speed until the end. Now, acceleration, that's basically the change in velocity. So when it's asking for the acceleration to be 0, that means the velocity isn't changing. Now, at all points on here, it looks like the velocity is changing. It's just constantly changing, but there is an instantaneous moment where it's actually not changing. If we look at the gradient of this line, that's basically telling us the acceleration. The steeper this line, the faster the acceleration. So if we wanted to work out the gradient at a certain point, we could draw a tangent to the line at that point. Now, as we go up this line, the gradient is getting shallower and shallower until we reach this point right at the top, this point here. If I was to draw a tangent at this point here, then it's a straight line. That's got a gradient of 0. That means the acceleration is 0. So now we can just draw a line straight down from there. It's halfway between two boxes. We want to establish what that point is there. So first thing I do is I look at the gap here. So I've got from 5 going up to 10. That's a gap of 5. And that's across 10 boxes. So if I've got a gap of 5 across 10 boxes, then I have to divide that gap between the 10 boxes. Each one is 0.5, or half. So I'm going from 5, 2 boxes are going to take me up to 6. Then an extra half a box, half of 0.5 is 0.25. This is in fact going to be about 6.25. There is a bit of tolerance in the mark scheme of what you're allowed there. That seems to be the most precise value of what that is. Next, we need to work out the distance travelled in the last 15 seconds. So we're going to get the last 15 seconds. It ends at 25, so if we count back 15, that takes us to 10. So we want to know the distance travelled through this portion here. Now if we were to do our formula for distance is equal to, okay, a lot of people get confused about this, but even if you don't know it, you can kind of work out what's going to happen. Think about speed and time individually. If you increase your speed, does that increase or decrease the distance you're going to do? And it's going to increase. So speed we're going to have as a numerator and not divide by it. And then time, if you're going the same speed but going for a longer time, yes, that's going to increase the distance as well. So distance is equal to speed times time. Now we're dealing with velocity, but for the purposes of this equation, it still holds because speed is just a scalar quantity of the velocity. Now looking at what effect this has on the graph, if we were going at a constant velocity and we were going for 15 seconds at 10 meters per second, then we're essentially going to do the speed, that's 10 times by the time, which is 15, 10 times 15, that's going to give us 150. Now that essentially actually gives us the area underneath here. This area here, that's 150. But we don't have a constant velocity, it's changing, we're decelerating. The simplest way we can do this is to simply look at the average velocity. Now clearly 20 is the average because that cuts it in 2 down the middle. So we could do 20 times 15 and that would give us 300. So he's travelled 300 meters in that last 15 seconds. Another way we could do this is calculating the area underneath here. The area trapezium often throws people off, but you don't have to remember the formula. If you do, that's fantastic. You can just split it into 2 triangles if you wish to. Or another way of doing it is splitting it. So you've got a triangle up here, and you've got this as a rectangle. Now this side here, from 10 to 25, that's the height of a trapezium. I'm going to label this side A and this side B. If I wanted to work out the area of this triangle here, I can apply my formula, which is half times the base times the height. In this case, the base is A and the height is H. And then I'm going to add the area of this triangle here, which is half B times the height. If I do a bit of playing around with this, I can bring out half as a factor, half, and then also A plus B, and I get this formula here. This is the formula which we're looking for the area of the trapezium. You can also consider it as taking the mean of both sides A and B. If you add those both together and divide by 2, you're essentially finding that average here, and that's essentially turning it into the area of a rectangle. So we can just put the numbers into this formula. We can have half A, which if we read across here, is 22, and then plus B. B is 18, and we're timesing that by the height, which is 15. And if we do the maths on that, we're going to get 300. Just to verify that, 22, add 18. I'd add the 8 first, so that gives me 30. Add another 10, that gives me 40. Half of that is 20. We've got 20 times 15 again. And that's going to give us 300.